Determine the limit as x approaches 0 of f of x. So the limit as x approaches 0 from the negative side is going to be the limit as x approaches 0 of, look, that's the first one. So it's going to be the square root of minus x. You plug in 0 and you get, plugging in 0 here, that's 0. Nice. See what else they say now? They say determine whether the limit exists. To determine whether the limit exists, we need to check if the limit from the right is the same. But no, the limit don't exist because x approaches 0. Well, let's check and see. So it is when you plug in, when you're approaching 0 from this side, you're getting 1. When you're approaching 0 from the right, you're getting 1. And so no. So no. So we can tell them that the limit as x approaches 0 from the right, limit as x approaches 0 from the right of f of x, that's equal to 1. Since the limit is equal to 1, since the limit is equal to 1, which is not equal to the limit, it's now not equal to, it's not equal to the limit from the left-hand side. Since the limits are not equal, then what do we know? We know then that the limit doesn't exist. So we can tell them hence the limit don't exist. Hence the limit does not exist. Since the limit don't exist, it's not continuous. Oh, determine if it's continuous at 1. That's a different question. Okay. To determine if it's continuous at 1, first we need to check if f of 1 is defined. So f of 1 is equal to 1. So first, f of 1 is equal to 1. Okay. Now we need to see if the limit as x approaches 1 is the same. Now, yes, they're the same. The limit as x approaches 1, the limit as x approaches 1 of f of x is equal to 1. So since the limit as x approaches x is equal to 1 and f of 1 is equal to 1, yes, yeah, it is continuous. So yes, f is continuous at x equal 1 since the limit is equal to f of 1. Since the limit is the same as f of 1, yes, it is continuous. Nice. So it is continuous at x equal 1. Nice. All right. Now part B says, determine the point at which the curve is parallel to the line. So if you have a curve, I always like to sketch something to get an idea. If I have some curve, right? Anywhere the curve is parallel to the line, that means the gradient of the curve is equal to the gradient of the line. So the first thing I need to find out is the gradient of this line. Make y the subject, I would get y is equal to, from this, y is equal to 6. Bring over this, bring over y is equal to 3x plus 6. That is y is equal to 3x plus 6. And so the gradient is equal to 3. Since the gradient is equal to 3, I'm good. I need to find the gradient of this curve now. So y is equal to x times the root of x. I don't like how that looks. So I'm going to write it as x times x to the half. Going to write it as x times x to the half. Then I'm going to find dy by dx. So now dy by dx is equal to, keep the first times the differential of the second. The differential of the second is carry down the power, which is a half, subtract 1 from the power, which is x, to the minus half, carry down the power, subtract 1 from the power, plus, keep the second, x to the half times differential of the first, which is 1, and we're going to set dy by dx equal to 3. Then we're going to solve for x. So this part is really simplifying to be x dividing by, this look like 2 root x, so it's x over 2 root x plus, this is now, x to the half is still root x, and this is equal to 3. So to solve this equation, or root x, not root 3, root x. To solve this equation, let's multiply through by 2 root x. Multiplying through by 2 root x, we're going to get x plus, we're going to get x plus 2 root x times root x is, root x times root x will give you x, so this becomes plus 2x, and that's equal to 2 root x times 3 is 6 root x. Now 2x plus x is 3x, and so 3x is equal to 6 root x. Now I'm not gonna lie, this part right here might trick up a lot of people, but when you're solving questions like these, just think of root x as y, and so this is like, if you're to call, let y be equal to, well, don't let y, let u. Given that y is x times root x, call it u. If you're gonna call u to be root x, then this makes the question a lot easier. Let u be equal to root x. If you call u root x, then it looks a lot simpler. Really and truly, you're solving 3u squared minus 6u equals 0. Now this looks pretty easy. You can divide through by 3, and you're going to get u squared minus 2u is equal to 0. And so you're getting that u is equal to 0, or u is equal to 2. If u is equal to 0, then that means that u is root x, and so x equals 0. Nice. Over here now, if u equal 2, to get x, you square both sides, and so x would be 4. If x is 0, you can find y, and so y is equal to, when x is 0, you have 0 times 0 is 0. And right here, you're getting 4 root 4 as y. So right here, you're getting y is 4 root 4. All right. So that is it. So the tangent to the curve at these 2 points are parallel to the line. All right. So the tangent at these points are parallel to the line. So we can tell them the tangents at 0, 0, and 4, comma, 4 root 4. Where's the square root? Don't know to put the square root, so let's write that. And 4 root 4 are parallel to the line. All right, nice and easy. Solved. Nice. Moving along, it says a function is given by y is equal to sine squared cos x. Show that the x-coordinates of the stationary points of y are n pi and plus or minus pi by 2 plus 2n pi. So first thing, stationary points occur when dy by dx equals 0. So first, find dy by dx. dy by dx is going to be equal to, we carry down the power to get 2 sine, carry down the power to get 2 sine of cos x, and then we multiply it by the derivative of cos x. The derivative of cos x is minus sine, is minus sine x. So that's dy by dx. So you might want to write it that dy by dx is minus 2 sine x times the sine of cos x. That's dy by dx. And remember, the stationary point is going to occur when dy by dx is 0. So we can always tell them that at a stationary or at a start point, dy by dx is equal to 0. So we're going to set this derivative equal to 0. Setting that equal to 0, it implies we can throw away the minus 2. So that implies that we're solving sine x times the sine of cos x equal to 0. If you're solving sine x or the sine of cos x equal to 0, then that means sine x equals 0. That means that sine x is equal to 0, or that means that the sine of cos x equal to 0. Now, when you're solving this part, now this is nice. Now, this part is relatively fine. If sine x equals 0, then the general solution will be sine inverse of 0, which is 0. Then you have pi. Sine inverse of 0 is 0, so you get 0 plus 2n pi. All right, it has n pi right here. So let's just draw our circle, because we know it's going to be 2 quadrants anyway. Let's just check it out, 2 quadrants. Sine inverse of 0 is 0. Over here, the solution will be pi. So we're getting that the general solution, so right here, I am getting that the x-coordinates of the stationary values of y. So the x-coordinate I'm getting right here, this is telling me that x equal 0, or x is equal to pi. That's what I'm getting. All right, x is equal to 0, or x is equal to pi. But you can just multiply it by n. So in really and truly, x is equal to pi n. So we show this part is correct. So x is equal to n pi in reality. No matter what n is, it will still be 0, 5, 10, 20, don't matter. So x is n pi, so we show this part. So that part is shown. Now we need to show this part. Now if the sine of cos x equal to 0, then that means that cos x, which really and truly that means cos x is equal to 0, or cos x is equal to pi, but cos x equal to pi is not valid, and so really and truly we're looking at cos x being 0. Now, if cos x is equal to 0, then you're going to get two solutions. The solution in the first quadrant is going to be x is equal to cos inverse of 0 is pi by 2. So it's pi by 2 plus 2n pi. That's one possibility. But then it can also be pi minus pi by 2. All right, pi minus pi by 2, and pi minus pi by 2 pi minus pi by 2 rather. And so you're getting right here that it is plus or minus pi by 2 plus 2n pi. This is what we get for the cos of x to be 0. So those are shown. Nice and easy, that wasn't bad. Nice. Now it says determine the nature of the stationary point at x being n pi. To determine the nature of the stationary point, we need to find second derivative. So remember, dy by dx is minus 2 sine x sine cos x. So dy, I'm just writing down back what dy by dx was. So dy by dx was minus 2 sine x minus 2 sine x times the sine of cos x. Minus 2 sine x times the sine of cos x. That's dy by dx. And so if that's dy by dx, we can find d2y by dx squared. So d2y by dx squared is going to be equal to, we're going to have to use product rule. Keep the first, which is minus 2 sine x. Keep the first, minus 2 sine x, multiplied by the derivative of the second. When you differentiate sine of cos x, when you differentiate sine, you get cos. When you differentiate sine, you get cos. So you're going to get the cos of cos x multiplied by the derivative of cos x, and the derivative of cos x is minus sine. So it's times minus sine plus, you keep the second is sine cos x multiplied by the derivative of the first. And the derivative of the first is when you differentiate minus 2 sine x, you differentiate sine, you get cos, so you get minus 2 cos x. I know it looks all weird, but it's nothing to worry about. Let's pretty it up. So prettying it up now, we're going to get that d2y by dx squared is equal to, minus and minus give us plus, and so sine times sine give us sine squared. So this becomes 2 sine square x. Then right here now we have 2 sine square x cos x times the cos of cos x times the cos of cos x minus, now 2, so it's going to be minus 2 cos x times the sine of cos x. And then at this point now, at x equal to at x equal to n pi, at x equal to n pi. No, it doesn't matter what n is. It doesn't matter what n is. Give n a value like 1. The second derivative is going to be equal to, give n a value like 1. So plug in when it's pi. You get 2 times sine square x, 2 times the sine of pi square times the cos. Just plug it in pi and see what we get. 2 times the sine of pi is 0. So all of this is 0. All of this is 0. And then down here we're getting minus 2 times the cos of pi. This part works out to be 2. So we get 2 times the sine of the cos of pi. You're getting negative. So you're getting negative 1.7, which is less than 0. And so at n pi, it's a maximum stationary point. So we can tell them this is a maximum stationary point. Maximum stationary point at x equal n pi. Nice and easy. Moving right along, question 6, integration. Question 6 says use the substitution u equal 1 minus x to determine the integral of x times 1 minus x squared dx. So using substitution, I like to call my integrals I. I don't know about you, I like to call them I. So calling my integral I, I'm getting that I is equal to the integral of, now using the u substitution, let me write down u up here. U is 1 minus x, and so du is equal to 1 dx. Du is equal to 1 dx. So that means that if you're to make x the subject up here, you'd be getting that x is equal to, make x the subject, you would get x is 1 minus u. X is 1 minus u. So this integral will become x is now 1 minus u multiplied by 1 minus x is now u. So 1 minus x all square is u square du. And so this works out to be 1 times u square is u square, and minus u times u square is minus u cubed du. Now you can proceed to integrate normally. You add 1 to the power, so you get u cubed divided by the power 3 minus, add 1 to the power, u to the 4 divided by the power of 4 plus some constant c. Nice. So going ahead now, we have I is equal to u cubed. What is u? We resubstitute back what was u, which was 1 minus x all cubed divided by 3 minus, in bracket, 1 minus x to the 4. This is being divided by 4 plus some constant c. Nice. Nice and easy, soft. Moving right along. It says, given that f of t is equal to 2 cos 2t, and g of t is equal to 4 sine 5t, show that the integral of f of t plus g of t is the same as the integral of f of t plus the integral of g of t. So first, f of t plus g of t, if you add them together, f of t plus g of t, that'll be equal to 2 cos t plus 4 sine 5t plus 3 cos t, and that would be equal to 2 cos t plus 3 cos t is 5 cos t plus 4 sine 5t. Nice. That's f of t plus g of t. So now if I were to integrate f of t plus g of t, integrate f of t plus g of t, then that's what I'll be integrating. I'll be integrating 5 cos t plus 4 sine 5t. So that's what I'll be integrating, f of t plus g of t. That's going to be equal to the integral of all of this, which is 5 cos t, 5 cos t plus 4 sine 5t. Nice and easy, soft. So if this is what you're integrating, what we get is the integral of 5 cos t. When I integrate cos, I'm going to get sine. So I'm going to get 5 sine t right here, 5 sine t, plus when I integrate sine, I get minus cos. So I don't need to put plus, I just change all of this to minus. When I integrate sine, I get cos, so it's going to be 4 cos 5t. And then I divide it by the differential, which is 5. So this is what I get when I integrate them. I get 5 sine t minus 4 over 5 cos 5t. Remember to put plus here, constant of integration. So I can just put the plus c in front of it. I can put a plus c plus this, meaning there's a constant. Now, if I were to evaluate now the integral of f of t plus the integral of g of t, evaluate the integral of f of t plus the integral of g of t, what I'll be working out is the integral of f of t is 2 cos t, so I'll be integrating 2 cos t plus the integral of g of t. The integral of g of t is 4 sine 5t plus 3 cos t. So you have 4 sine 5t, 4 sine 5t plus 3 cos t. Nice. This is what we have. So now integrating these two, what I get now is this is equal to the integral of 2 cos t is 2 sine t. You get 2 sine t. Then when you integrate 4 sine 5t, you get minus 4 cos 5t, and then you divide it by the differential of 5t, which is 5, plus when you integrate 3 cos t, you get 3 sine t, plus some constant of integration. Let's call this constant k. All right, and so this works out to be 2 sine t plus 2 sine t plus 3 sine t. Well, just to make it absolutely look like them equal, let's call the constant c. You always want it to look, identical. So sine t plus 3 sine t. Start with the constant first, so it is c plus sine 2 sine t plus 3 sine t is 5 sine t. And then you have minus 4 over 5 cos 5t. So as we can clearly see, we're getting the same thing. Nice and easy, soft. So since we're getting the same thing, you can just show them, see it here. This is what you get up here. This is what you get down here. They're the same thing. And so we can conclude that indeed the statement is true. So we've shown it. Nice. Just give them a concluding statement. Hence, or therefore, the integral of f of t plus g of t. Hence, the integral of f of t plus g of t. It's good when you just give them a concluding statement. Show them that you know that you were doing. Hence, you show them that the integral of f of t plus g of t. Don't forget to write a dt. I don't write it because of space. That's equal to the integral of f of t is equal to the integral of f of t plus the integral of g of t. Nice and easy, soft. No issues whatsoever. Nice. Moving right along. This says calculate the volume of the solid, rotate by sine x between pi by 2 to pi and y equals 0 around the x-axis. Now volume is equal to pi times the integral from a to b of y squared dx. Just writing down the formula of volume, this is how we find volume. So in this case, the volume is going to be equal to pi times the integral of, now a is pi by 2, so going from pi by 2 to b is pi, and we're integrating y squared, y is sine x, and so y squared is sine square x. This is sine square x dx. Now, you cannot integrate sine square dx like this, right? You cannot just add 1 to the power, divide by, that's crazy. You have to use trig identities to substitute sine square and cos square. So now, going back, we know that cos 2x, we're putting it up top here. We know that cos 2x is equal to 1 minus 2 sine square x. Yeah, man, cos 2x is equal to 1 minus 2 sine square x. So from this, we can make sine square x the subject by getting that sine square x is equal to cos 2x. Sine square x is equal to 1 minus cos 2x over 2. All right, if you make sine square the subject right there, you see that sine square x is going to be equal to 1 minus cos 2x over 2. One minus cos 2x divided by 2. All we did was make sine square the subject, so no issues there at all. No issues whatsoever. Nice. So all we're going to do is make that substitution. So the volume is now equal to, I'm going to factor out a half and write it as pi by 2 times the integral of 1 minus cos 2x 1 minus cos 2x dx. And don't forget that we're integrating from pi by 2 to pi. So now you may proceed and do this. So proceeding, we're going to get pi by 2 times, when we integrate this, what we're getting is, when you integrate 1, you get x, minus, when you integrate the cos of 2x, when you integrate cos, you get sine, so it becomes sine, when you differentiate sine, you get cos. Yes, we're right, we're fine. When you integrate cos, you get back sine, so you get sine 2x divided by 2, and we're integrating from pi by 2 to pi. So we're integrating from pi by 2 to pi. So all we need to do is plug in now x as pi. So we have pi by 2 times, plugging in x as pi, we get pi minus, well, plugging in pi right here, the sine of 2 pi is 0. I'm positive of that, the sine of 2 pi. The sine of 2 pi, yes, the sine of 2 pi is 0, so we get pi minus 0. We get pi minus 0 minus, when we plug in pi by 2 now, we're going to get pi by 2 minus, when you plug in pi by 2 here, 2 times pi by 2 is, 2 times pi by 2 is pi, and the sine of pi is also 0, and so just get pi minus pi by 2. But pi minus pi by 2 is pi by 2, and pi by 2 times pi by 2 is pi squared over 4. So the answer, the volume is pi squared over 4. And remember, volume is units cube. Remember to tell them it is pi squared over 4 unit cube. That's the volume. Pi squared over 4 units cube. Nice and easy, soft. All right. Well, this part of the question says, solve the differential equation dy by dx is equal to x times x, the square root of x squared plus 1 over y. So let's solve this easy differential equation. We call this easy differential equation. So we cross multiply. If you cross multiply, you're going to get y dy is equal to, cross multiply the x, you get x times the square root of x squared plus 1. No, this part might be tricky to integrate. You might say, sir, integrate x times x squared plus 1. Oh my God. So all you're going to do is integrate both sides now. And so the integral of y dy is y squared over 2. And so y squared over 2 is equal to this integral. But you might say that integral look tough. I agree with you. I agree. This integral look tough. So I'm going to cross multiply. When I get, let's not do it in 2 steps. So y is equal to the integral. Y squared over 2 is equal to the integral of x times the square root of x squared plus, why did that happen? So it's x times the square root of x squared plus 1. Now, once you get to this stage, I want you to notice that you can cross multiply the 2 and say, so y squared, indeed, and so y squared is now equal to, multiplying the 2, you get the integral of 2x times the square root of x squared plus 1. Yeah, man, an easy question, butters. So it's 2x times the square root of x squared plus 1 dx. Now that this is what you have, you can use u substitution to say maybe let u equal x squared plus 1. If you don't see what, go and use u substitution. If u is x squared plus 1, then du is going to be equal to 2x. Nice. So if du is 2x, then that implies that y squared is equal to, this part becomes u, and 2x dx become du. So it becomes y squared is equal to the integral of the 2x dx is du, and so now we just have the square root of u, which is u to the half du. So what we're getting then is y squared is equal to, when you integrate u to the half, you get u to the 3 over 2. Instead of writing u over 3 over 2, I'm going to write 2 over 3 u to the 3 over 2. I'm going to write it as u cube square rooted plus some constant c. Yeah, man. Nice. So to finish this off now, you're going to have to substitute back what was x. What was u? U was x squared plus 1. So in this case, we're going to say, so y squared is equal to 2 over 3 times the square root of u squared is now x squared plus 1 is now x squared plus 1 x squared plus 1 cube plus some constant c. Now it said solve this differential equation. So that means that we need to find this constant. And they gave us when x is 0, y is 2. So when y is 2, 2 squared is 4. So let's finish it around here. So what we're getting is 4. Let's do it bright now. So 4 is equal to x is 0. This becomes 2 over 3. X is 0. 0 plus 1 cube is 1. The square root of 1 is 1. And so 4 is equal to 2 over 3 plus c. So 4 is equal to 2 over 3 plus c. So subtract 2 over 3 from both sides. And so c is equal to 4 minus 2 over 3 is 4 minus 2 over 3 is 10 over 3. So I get 10 over 3. So start to check it in my calculator. And so what we finally get then is y squared is equal to 2 over 3 times x squared plus 1 cube, x squared plus 1, all of this is cube, and then all of that cube is square rooted plus 10 over 3. Nice and easy, soft. That's how you solve this differential equation. There is no sugar to it, no spice. Everything was just nice and easy. So that takes care of this paper. I really hope it was fun for you, as much fun as it was for me. And so definitely stay tuned for more. And I wish you all the best prepping for your exam.